Hello, everybody. Firstly, thanks to Test Drive for providing me this opportunity. I'm going to be talking about system design and its importance to testers. A board bug is a reproducible problem. Testers should be able to easily reproduce it following the steps and scenario that help them find the bugs. The developers would be able to fix it following the same. Haitian bugs are opposite of board bugs, which are hard to reproduce, hard to fix, and they are side effects of the problem that occurred much earlier, such as overrunning an array or accidentally dereferencing a pointer after the object to which it points has been freed. Such errors can corrupt the application in a way that will cause it to crash, but not until the corrupted data structure is finally referenced, which may not occur until long after the bug actually was excised. Because such a bug is typically a symptom of the underlying problem rather than an instance of the true problem itself. Hessian bugs are impeccably sensitive to the order of execution. Even with identical inputs, a program that crashed once may run correctly back in the laboratory. Developers are likely to discover and fix board bugs, which are easily localized and reproducible source of errors. Hessian bugs are fuzzy and hard to pin down. Often these bugs are actually symptoms of some other bug, which doesn't cause an immediate crash. The developers will tend to work around them, but may find extremely hard to fix in a convincing way. The frequency of such bugs diminishes very slowly over life cycle of an application. Not surprisingly, the major source of crashes in a mature software system turns out to be Hessian bugs, and with distributed systems, we find many of Hessian bugs. Distributed design and systems are complex, which has many moving parts, and hence it's important to focus on this. I would encourage you to research and read on these further. Overcoming failures in distributed system is very important. What does system design mean to testers? With distributed architecture, why is it so important? System design is a blueprint that is created before any product is developed. System design talks about architecture, how different components fit together, what are the trade-offs. It also helps to provide sufficient information about the system as a whole. What does system design mean to testers? Why is it important for testers to understand system design and take part in that to contribute towards building the overall product and making it successful? This is a system design I created for video upload and download product. Based on the requirement, this system design could actually change. For example, like what are we trying to achieve with this product? What is important from users and business standpoints? And based on many such reasons, the system design could actually change. This is the design where end users are going to hit the API gateway, upload or download the videos. These images depict how many components work together and come together to form a complete system. It's important for testers to be glass box testers, should be able to see through the entire system. Testers need to ask, how are they going to test data transfer between different data sources like RDBMS and NoSQL? Testers can help brainstorm about consistency versus availability and impact on performance to make the overall system better. How are we going to test to ensure no data is missed when data is broken into different sets, which is being addressed by adding Q in the first image when compared to the second one? Some of you could argue why testers need to be part of this and understand, but as a tester, you need to understand the system better to design your test better. Also, to secure a seat in a system design table, it's important that testers show the value they can bring in to make these designs better. Testers need to think about testability. Testers need to ask how performance of the system could be impacted. Testers need to talk about likely security loopholes in the design. Testers need to ask how are we going to plan for data to conduct end-to-end or integration testing. Testers need to talk about performance testing and cost, how it would be impacted without making the right cache implementation, and many others. Looking at the design as a tester, we could ask, how are we going to deal with implementing and testing complex transactions and queries that span multiple microservices or data stores? How are we going to deal with testing and managing multiple relational and non-relational database? So as a tester, how will we design if a notification is lost in the system? How will we test for it? How will we test for those kind of impact? Likewise, there are many such examples where testers have to understand system design and participate in the system design. It's all about bringing our testing mindset to make the system design robust. As a tester, it's important to learn basics of architecture, understand what is distributed and microservice-based architecture, how testing is changing with migration from monolith to microservices, understand about data stores, think like an end user, how to visualize, read, and understand system design, understand non-functional requirements like high availability, fault tolerance, redundancy, scalability, latency, consistency, eventual consistency, and many others. The key takeaways are learn about system design and do not ignore, have basic understanding of distributed architecture, components that forms the distributed system, discuss often how a system works internally, be a glass box tester, think about bigger picture of making the product successful. With that, I have tried my best to explain system design and its importance to testers, which are extremely important for testers and testing community. Credits to Presentigo, Amazon, and uh, a book on distributed architecture. About me, I'm working as an engineering manager. My LinkedIn profile details if you want to connect with me. Thank you very much.